Okay, now we have another question on the board. It says, if you look at this, we have two blocks. Two blocks are placed on this rough surface, and over here, you are seeing something like this. This block is 6.5 kg. 6.5 kg. Okay, so it says three bodies X, Y, and Z of masses 3 kg, 4.5 kg, and 6.5 kg respectively are connected by a light inextensible string as illustrated in the diagram above. If X and Y are placed on a rough surface of coefficient of friction 0.4 and 0.7 respectively, calculate the magnitude of the normal reaction on X and the normal reaction on Y, and then the frictional force between X and the surface. Right? Then the next one they say we should find is the frictional force between Y and the surface, and then the tension in the string. Okay, so let's come back to this. Now what to do now, we'll first take block X, then later we'll take block Y, and then we'll take block Z. Alright, okay, quickly let's do that. I say consider block X. If I take block X out, I'll have this okay, this is the surface, the horizontal surface, and then this is the block X. Now look for the weight of the block, the weight which is acting downwards. The weight W is equals to mg. Now the weight W will be equals to, the mass of the block is 3 kilogram multiplied by acceleration due to gravity was given to us as 10 meters per second square. That's G times 10 meters per second square. That will be 30 Newton. The weight of the block, the weight of that block is 30 Newton. Now the next thing I'll look for is the normal reaction that acts at 90 degrees to this plane. Normal reaction R. Okay. Now remember we are told that the coefficient of friction is 0.4. That is, it said if X and Y are placed on a rough surface of coefficient of friction 0.4 respectively. So we take that the coefficient of friction for this block mu is 0.4. That's the coefficient of friction for the block, 0.4. So that means that there's an effort acting on this string, which is tension force acting on the string, and if the direction of motion is this way, if direction of motion is going this way, friction force will act this way. Friction will act this way. F is equals to mu R. So my frictional force is equals to the coefficient of friction times the normal reaction. Okay, and the coefficient of friction was given to us as 0.4. Coefficient of friction is given to us as 0.4. So if the block is going this way as a result of the tension force acting on the string, that is at this string, there is a tension force acting on this string. There's a tension force acting here as well. So as the block is going like this, direction of motion is like this, friction will act opposite the direction of motion. And friction force must act between two surfaces in contact. The surfaces in contact is the lower portion of this block and this rough horizontal surface. So that is where it is acting between two surfaces in contact. I have my friction force F. Now the next thing I'll do now, say the upward vertical force is equal to the downward vertical force. Okay, and the upward vertical force here is the normal reaction R. Downward vertical force is the weight of the block, but we have the weight of the block as 30 Newton. We say, but the weight of the block is equals to 30 Newton. It then implies that R will be 30 Newton as well. Okay, the weight is 30 Newton. That means that the normal reaction will also be 30 Newton. You see, therefore R is also what? 30 Newton. Okay, we have solved the first question. So the first question says the normal reaction on X. It says, therefore normal reaction on X is 30 Newton. Okay, now if frictional force is equals to coefficient of friction times the normal reaction, then I can find the coefficient of friction. Coefficient of friction is friction force over the normal reaction. Okay, it's frictional force over normal reaction. Okay, so that is it. That is friction force, frictional force over normal reaction is equals to my coefficient of friction. Now we have this. Let's assume that we are looking for the frictional force. F equals to mu arrow. Then F now will be equals to the coefficient of friction of that block is 0.4 times the normal reaction is 30 newtons. Okay, so that means that my frictional force F will be equal to, so my frictional force F is 12 Newton. Okay, so I've gotten the frictional force. If you can recall, they say we should find the frictional force between X and the surface. Frictional force between X and the surface, of which we have solved that one. And we have gotten this. You say therefore, frictional force between X and the surface is 12 Newton. Okay, then I can then continue. Now I'll suspend this block and go over to the next block. I say consider block Y. Consider block Y. If I consider block Y, I'll be having something like this. Now look for the weight of this block. The weight of the block will act downwards. The weight is equals to mg. Okay, and then of course I'll find the normal reaction. Normal reaction will act at 90 degrees to the surface. Okay, so quickly let's find the weight of the block, which is mass times acceleration due to gravity. And don't forget that the frictional force between X and the surface is 12 Newton. Please indicate it. Indicate it that F here is equals to 12 Newton and that the normal reaction is 30 Newton. Okay. Alright, so we have solved that. Okay. We have solved that. So I have to indicate it, F12 Newton. Now we are going to block Y. Let's find the weight of block Y. Find the weight of block Y. Now remember that the mass of block Y is 4.5 kg. So the weight of block Y is mg, which will be equals to 4.5 kg, which is the mass. The mass is 4.5 times 10 meters per second square. That is acceleration due to gravity is 10 meters per second square. That means that the weight now will be equals to 45 Newton. Okay, the weight of the block is 45 Newton. That's 4.5 times 10. It's 45 Newton. Okay, that is it. So I've gotten the weight of the block doubly as 45 Newton. That's the weight of the block. Then I can look for the normal reaction. The normal reaction now. You see upward vertical force is equals to downward vertical force. So the upward vertical force there is the normal reaction, arrow. The downward vertical force is the weight, W. Say but W is equals to 45 Newton. That means, say therefore the normal reaction, arrow will be equals to 45 Newton. So I've gotten that. Say therefore normal reaction on block Y is 45 Newton. That's 45 Newton. Now, you can then find the frictional force. If you observe here, there is a rope that is connected to this block and is pulling this block this way. Now there is a tension force acting on that rope, tension T. So I'll come back there. I will indicate the rope. that pulls the block towards the right, and the tension force is there. This is showing us the direction of motion. Direction of motion. So impending motion is moving towards the right, and it implies that frictional force will act opposite to the direction of motion. So friction force will act opposite the direction of motion, act this way. That is F equals to mu r. Friction force is equals to mu r. Okay, friction force is mu r. It will act opposite the direction of motion, and it will occur between two surfaces in contact. So I can indicate, say to obtain the friction force, F will be equals to mu r. Okay, and then we are told that they say but the coefficient of friction mu between the block and the surface is coefficient of friction between the block and the surface is 0.7. okay, that is between the y block, which is 4.5 kg block, and the rough surface is 0.7. okay, that is it. So mu is 0.7. Now I can find the value of F. I put it there and also use the normal reaction. That means that friction force will be, so it means that F will be equals to mu r. So friction force will be equals to 0.7 times the normal reaction is 45. Is 45. That means that my friction force F, if I multiply this, in place of mu I wrote 0.7. So 0.7 times 45 will give me, so if I multiply this now, we're having 31.5 Newton. That's the frictional force. It's 31.5 Newton. Okay? So therefore, the frictional force between y and the surface, frictional force between y and the surface is 31.5 Newton. Okay, so I can indicate it there that F here, F is equals to 31.5 Newton, and normal reaction is equals to 45 Newton. 45 Newton, F is 31.5 Newton. Okay, so I will still go back to block. I say applying Newton's second law of motion to block X and Y. You see, to block X, let's consider block X. To block X, if you can recall vividly, this was what we had for block X. This was what we had for block X. What we had for block X, you see that there was a tension force acting like this, tension T, and the frictional force was acting this way. Frictional force there was acting, and we had the frictional force F as 12 Newton. Okay, so that's what we need. Now, Newton's law now is telling us that F is equals to ma. The second law of motion is F equals to ma. That's what we are going to make use of. So I can say that F prime is equals to ma, and this F prime shows us the summation of forces. The summation of forces. Now, it means that this one going like this is positive x, and the one coming this way is negative x. That's my direction of motion. So my tension force now will be positive. I'm taking the summation of forces. Tension is positive plus this one coming like this, friction is negative, minus what? F is equals to the mass of that block. Mass of block X is 3 kg. That is it. The mass of block X, if you observe, is 3 kg. Okay, so I'll come here now. That is 3 times A. 3 times A is the linear acceleration. So plus times minus is minus. I have the tension minus F is equals to what? 3A. Okay. Alright, my friction force is 12 Newton. That is this 12. So my tension minus 12 equals to 3A. Okay, tension minus 12 equals to 3A. I can call this one equation 1. Call this equation 1. Then I move over to block, apply Newton's second law of motion to block Y. So this is for block X. Okay, so I say to block Y. Okay, that is using Newton's second law of motion, F prime equals to ma. This F prime shows you the summation of forces. So we come back here. We know that this one coming like this is positive plus X. So I'm going like this is positive X. This one coming like this is negative. This direction is negative X. Okay. So positive X, negative X. That implies that my tension is positive and my friction force is negative. So this is positive T and negative F. Okay, so that is T plus open bracket minus F equals to the mass of the block Y. Mass of block Y is 4.5. Now the 4.5 times A. So plus times minus is minus. This is tension force minus friction is equals to 4.5 A. So this is T minus friction force is 31.5 Newton. T minus 31.5 is equals to 4.5 A. Call this one equation 2. Call this equation 2. Now I will then go over to the next block. The next block there is block Z. Consider block Z. I say apply Newton's second law of motion. Applying Newton's second law of motion to block Z. That's block Z. I'll take it out. Now I have this. This is the weight of the block acting downwards. The weight is equals to mg, which is the mass of that block is, if you observe, the mass of the block is 6.5. So the weight now is 6.5 times 10 meters per second square, 6.5 kilograms, sorry, times 10 meters per second square. Okay, so the weight will be 65 Newton. This is the weight of the block. And also you observe that there is a rope connected to this block. So tension force will act on this rope. There's a rope connected to the block. Look at it, this is the rope. And at this point, there's a tension force acting here. Okay, so that's what we just need. That's the free body diagram. We just took this component out. So this is it. Now, this is the direction of motion. The direction of motion is showing you that this block is coming like this. So acceleration due to gravity is showing this way. It's falling downwards. Now, since it is acting due to gravity, A is equals to plus G. So what then will be my sign convention? The sign convention now is showing us that if it's coming downwards, it is positive Y. And if it is going upwards, it's negative Y. Why? This is the direction of motion. Direction of motion is showing that acceleration due to gravity is, is acting downwards. So it is due to gravity. This block is moving due to gravity. So A is plus G. If it is going upwards, it is against gravity. That is minus Y at this point, or minus G. So going upwards is against gravity. Coming downwards is what? Due to gravity. So it's positive. If it's going up, it's negative. So taking the summation of forces now, it means that tension is going upwards, is negative. And the weight of the block is coming downwards, is positive. Alright? So quickly, we can say that say F prime is equals to ma. That's applying Newton's second law of motion to it. So that will give me the weight coming downwards is positive, this one going up is negative. That's minus T plus W is equals to ma. So minus T, the weight is positive, that is plus 65 is equals to, the mass of the block is 6.5. 6.5 times A. This will give me minus T plus 65 is equals to 6.5 A, of which I can call this equation 3. Okay, I can call that equation 3. Minus T is upwards, negative. Downward one coming down, downward is positive, W is positive. That's minus T plus W equals to MA, which is minus T plus 65 equals to 6.5A. Alright. Now what's the next thing I'll do? I'll solve simultaneously. I say solving simultaneously. Solving simultaneously. Take equation 1 out. Equation 1 is T minus 12 equals to 3A. Equation 2 is T minus 31.5 equals to 4.5A. And equation 3 is minus T plus 65 equals to 6.5A. That's equation 3. So what I'll do now is to tackle 1 and 2. That's I'll take 1 and 2 since block X and Y are on the same plane. So I'll tackle 1 and 2. I'll say equation 1 plus equation 2. Equation 1 plus 2. What will it give me? That's this plus this. That's T plus T minus 12. Minus 12 plus minus 31.5 equals to 3A plus 4.5A. Alright, so T plus T will give me 2T, and plus times minus is minus, so that is minus 12 minus 31.5 equals to 3A plus 4.5A will give me, that will be 7.5A, because 3 plus 4.5 is 7.5. So this now will be 2T minus 43.5 is equals to 7.5A. Okay. So now I have this, and I can call this one equation 4. 2T minus 43.5 equals to 7.5A. Now I'll tackle equation 3 and equation 4. Okay. If I consider 3 and 4, say consider equation 3 and equation 4. So solve them simultaneously. I'll have okay, so equation 3 now is minus T plus 65 is equal to 6.5A. That's equation 3. Okay. And then I'll write equation 4. Equation 4 is 2T minus 43.5 is equal to 7.5A. Okay, I call that equation 4. So what do I do now to ensure that they are similar to some extent? I'll use these two to multiply everything in equation 3. Then I'll use minus 1, the coefficient of T, to multiply everything here in equation 4. So I can say 2 times, no, equation 3 times times 2, and here now will be equation 4 times minus 1. Okay, so let's go. 2 times minus T will give me minus 2T. 2 times 65 will give me 2 times 65 will give me 130. Is equals to, then 2 times 6.5 will give me 13. That is 13A. So I can call this one now equation. I can call this equation 5. Okay. So I use 2 to multiply everything here. 2 times minus T is minus 2T. 2 times 65 is 130. 2 times 6.5 is 13A. That's 2 times 6.5A is 13A. Now we use minus 1 to multiply everything here. Minus 1 times T times 2T is minus 2T. Minus 1 times minus 3.5 is plus 43.5 is equals to minus 1 times 7.5 is minus 7.5A. Okay, that is equation 6. Got equation 6. So when I use minus 1 to multiply everything here, minus 1 times this is this, minus 1 times 2T is this, minus 1 times 43.5 is this, minus 1 times 7.5 is this one. Okay, so at this point now I can then I can say equation 5 minus equation 6 and subtract 6 from 5. Okay, this now will be, this will be minus 2T minus 2T. I subtract this from this, plus 130 minus 43.5 okay, is equals to 13a minus 7.5a. Okay, subtract this one from this one. Okay, so minus and minus is plus, so that is minus 2t plus 2t. Then subtract this one from this. That will be, so this will give me 86 plus 86.5 is equal to, minus and minus is plus, that's 13a plus 7.5a. Alright, so minus 2t plus 2t, minus 2t plus 2t is 0 to cancel out. Okay, so here now I'm left with what? 86.5 is equal to 13a plus 7.5a will give me, this will give me 20.5a. Okay, so if I divide by the coefficient of acceleration now, my linear acceleration will be 86.5 divided by 20.5. So linear acceleration A will be, so this will give me 4.22 meters per second square. That's the linear acceleration A. Now I can then go back to equation 1 or equation 2. This is equation 1. I say substitute A into equation 1. Equation 1 is t minus 12 equals to 3a. Or I can say substitute A into equation 2, which is t minus 31.5 equals to 4.5a. Or substitute A into equation 3. Equation 3 is minus t plus 65 equals to 6.5a. Any of them will give me the value of the tension T. So let's use equation 1. And if I substitute A into equation 1, I'll have substitute A equal to 4.22 meters per second square into equation 1. So this now will be, equation 1 is t minus 12 equals to 3a. This is t minus 12 equals to 3 open bracket 4.22. Okay, so this is t minus 12 equals to 3 times 4.22 will give me, this will be 12.66. Okay, if I collect like this one cross over here, so t will be equals to 12.66. Carry this one over here plus 12. So the tension force T will be equal to 24.66 Newton. Okay, so that is the tension. The tension in the string is 24.66 Newton, and the linear acceleration is 4.22 meters per second square. Then we have gotten the normal reaction in block X and block Y. We also got the frictional force between block X and the rough surface, and frictional force between block Y and the rough surface. Okay, so this is the tension. The tension in the string is that. Say therefore, can say therefore tension in the string is 24.66 Newton. That's the tension in the string. That's the tension. Tension in the string is 24.66 Newton. Okay, so that is everything we have done to that question. Okay, so the question on that friction. Friction is a contact force that occurs between two surfaces. Contact, and then you also observe that in friction, it says it opposes relative motion. It must oppose relative motion. So it acts in opposite direction to motion. Like you look at that block, as the movement of the block, as it is moving towards the right, friction will act to the left. Yes, if the block is moving towards the right, friction force will act towards the left. So it's a force that opposes relative motion, and it will occur between two surfaces in contact. So the tension in that string, tension T, we have solved it and we have gotten 24.66 Newton. Alright, so that is everything there we have to do. Okay, so we'll stop here, and then that is it. Alright, thank you.